Great. We are continuing with lesson 1, but we're moving on to our second big idea of the unit. And it is demonstrating and understanding that an equation shows equality on both sides of the equal sign. So both sides of the equal sign are equal. And then using that to create an expression to represent an equation and solve for the unknown. It sounds complicated, but we'll figure it out. Remember, we're looking this time at lessons 5 and 6. We've combined them both because one was one operation, adding, and the other one was subtraction, I believe. So we may be able to write an equation, write an equation to help us solve a problem, and we can use a letter variable to represent the part that we don't know. So Luke opened 20 packages of pencils, so that's our total. He gave out some of his pencils, so gave out, meaning given away, so minus something, because we don't know how many pencils he gave out. That's where our letter will be. And there were 6 left, so that's our final. So equal sign 6. So here we can use a variable to represent what's missing. We use a variable to represent the number of pencils given out. Let P represent pencils. Okay, let's make it a P. Okay. All right, so we've let P represent the number of pencils. The total number of pencils was 20. The number of pencils given out, well, you can do this either way, right? Plus the number that were left, so the 2 that would add to equal 20, or it could be 20 minus whatever, the number of pencils that would give us 6. So it can be written either way. Do remember that you always have to have the bigger number and then what you're taking away. So watch when you're doing a subtraction question that the bigger number is always first. We could also look at it as 20 minus 6 equaling the number of pencils, and that would still be P. So it can be written all 3 ways depending on how you interpret the question. All of them will still end up with the correct answer. So, well, let's check. 6 plus what is going to give us 20? Well, 14. So let's see. 14 is equal to 20 minus 6. Does this side equal 14 and does this side equal 14? Well, 14 is 14. 20 minus 6, yep, 14. So this equation works. 20 minus 14 equaling 6. Does this side equal 6? Yep. Does this side equal 6? Yep. Both sides are equal. Check. That one works. I'm going to write this one up here. 20 is equal to 14 plus 6. So now both sides have to equal 20. 20 equals 20. 14 plus 6, yep, equals 20. All 3 equations, as you can see, all 3 equations work, and all of them give you the answer of P. They tell you the number of pencils. That was 14. All right, let's take a look at another question. Marie has 36 emails in her mailbox. So 36. That's twice as many as she had last week. So it's 2 times as many as she had last week, which is the number that we don't know. So the number of emails we don't know. I'm going to make that E. Let's represent this as E as the number of emails, which we did. We could write this in 2 ways. So I've chosen to write it like this. Note, whenever you see it like this, where it's 2E without a sign in between it, it always means multiply. We just don't write it. Okay? Sometimes mathematicians prefer not to write all of it, and they prefer shorthand. This is their shorthand. So whenever you see a number with a letter right next to it, it means multiply. They just haven't written it that way. Okay. The other way you could look at this is the number of emails. Well, it's 36 divided by 2 because it's half as many, because it was twice as many that she had last week. So it would be half of what we have right now. Either of those will work. Well, let's try it. 36 divided by 2 18, not equal sign, is 18. And so that means the number of emails would be 18. So both of those sides would be equal. Or if we looked over here, 2 times 18, because that's what we've said the number of emails are, 2 times 18, is 36. So now both sides of the equation are in fact 36, and it works. So the number of emails then is 18. Either of those equations will work. All right, now we're continuing. This is lesson 6, the connect section. Still problem solving and still making equations and expressions within those equations to help figure out the answer. Wendy washed 72 windows in an apartment building. She had 98 windows to wash altogether. How many more does she have to do? So we could do that a number of ways. She has 98 total. She's done 72 already, plus some number of windows. That's going to equal 98. Or we could write 98 minus 72 equals the number of windows she has left. Either equation will work. So the guess and test method, 72 plus what is going to give us 98. And we can guess a number of times. It doesn't have to necessarily be correct the very first time. So we could try 72 plus 10, they've decided. Well, that's 82, so it's too low. I need some more. So this time I'm going to try plus 20. Well, that's pretty close, 92, still too low. Let's try 25. 72 plus 25 is 97. That's really close. I just need one more. So let's go with 26. 72 plus 26 is 98. So then we know the number of windows is 26. That is the solution to our equation. The other way we could do it is by what we call inspection. Inspection means to look at it, inspect it, and try to figure out what the number represents. 72 plus what would give us 98 might be that you do the subtraction. 98 minus 72 gives you the 26, so you know that's the number of windows. And then both sides of our equation are equal. Windows equals 98 minus 72. We've said the number of windows is 26, so this side is 26, and 98 minus 72 is 26, so this side is 26. Both sides are equal. That method is called inspection. All right, now it's your turn to practice. You're going to press pause and you're going to try each of these. Remember, you need to write an expression. Must have an expression for each of these, not just the answer. The expression is the important part for this lesson. All right, so let's take a look at our first equation, or first problem. Nadia has a bowl containing some beads. She and her 8 friends want to make bracelets. They plan to divide the beads evenly, so it's going to be in even groups. There are enough beads so that every person gets 9. So 8 groups of 9 times 9. And there's 1 left over, so 1 extra bead, which equals the number of beads in total. This would be my expression. I'm using inspection here to figure it out. 8 times 9 is 72, plus 1 would make it 73. So that means the number of number of beads is 73. Press pause and try the second one if you haven't already done so. The second one, let's take a look. Gould is waiting in a line to get tickets for a concert. Including Gould, there are 1,001 people in line. There are 56 people in front of Gould. How many people are standing behind him? So we have 56 plus something, the number of people perhaps, that's going to equal 1,001, but that includes him, I believe, so we're going to go 1,000. Now we're going to use guess and test to try to figure it out. Well, I know it has to be at least 900 and something, so I'm going to try 56 plus, it's a little bit less than 50. Let's go 940 and see what we end up with. So 940 plus 56, 6 plus 0 is 6, 4 plus 5 is 9, and 9. So that's 996. I'm 4 short. So I'm going to make 94, 98. 56 plus 98. Well, let's try that now. 56 and 98. 6 plus 8 is 14. Carry the 1. 9 plus 6. Oh, goodness. 996. My mistake. Let's take a look again. 940. So now I'm going 948. Okay, so 56 plus 948. Make sure you line up your ones. 6 plus 8 is 14. Carry the 1. 5, 9, 10. Carry the 1. It's 1,004. Now I'm 4 too much. Oops, I added 8 instead of 4. So, okay, well, that's no problem. That's what guess and test is all about. So I'm going to take actually 4 away from there. So it's going to be 56 plus 944. I'm going to see if I can make us some room here. Move everything up. 56 plus 944. 6 plus 4 is 10. Another 10. And 9 plus 1 is 10. So that is our 1,000. So it would have to be 944 beads is what I figured out. Sorry, 944 people. This one was people, not beads. That were standing behind gold. So either method works. Use whichever one happens to work for you, and it doesn't necessarily mean that you will use always the same method. Sometimes when you look at a problem, one method will pop out to you more than another. Sometimes it won't, and you really have to try guess and test to try to figure out what works. And remember, the first guess doesn't mean that's the right answer. You may have to guess repeatedly, and if you make a mistake along the way, not a problem, you just fix it in your next guess. All right, at this point, you are moving on to the concept practice. Now, this is for all operations, adding, subtracting, multiplying, dividing. So, whoops, shucks. Page 22, numbers 1, 2, 4, 3, 4, and 6. And page 24 and 25, numbers 1, 2, 5, and 6. Remember, you have to create the expression. That is the whole point. And then use that equation to solve for the unknown, remembering that both sides of the equal sign are equal. Remember, if you have questions at any point along the way that you ask, remember to always, always, always show all of your work so you can get effective feedback.